All right, so we have heard of trig. You've heard of sine, cosine, tan. They're reciprocal functions. All of those are sinusoidal functions. It just means it's a trig function. It's periodic. We know what sine is. It's opposite over hypotenuse, but what does it actually mean? So let's get into what sine actually means. So all these are functions. Sine is a function that goes through the origin. It looks like this. Let me erase some of this. Okay, yeah. Is this an odd function or is this an even function? Or neither? Remember what they are? It's a reflection. They're both types of reflections. One of them is a reflection on the origin. The other one's a reflection on the x-axis. So this is an odd function.
Mhm.
What you have in quadrant 1, you have in quadrant 3. What you have in 2, you have in 4. So it's a reflection about the origin. So sine functions are odd. What odd function is if you put in a negative value, f of minus x, that negative value comes out of the function. That's an odd function. Whereas cosine does not go through the origin. Cosine goes through 0, comma 1, just like an exponential function. So the plot of cosine would look something like this. Let me make it straight. Is this an odd function or an even function? Even function is something that's reflected on the y-axis. So this is an even function, okay? It's like putting a mirror on the y-axis. An even function, when you put in a negative x value, the negative value completely disappears. You can show this graphically. So let's say this is some negative x value. This is the y value. Let's say that's negative 1. At positive 1, let's say this is positive 1. This is the y value. What do you notice? They're the same. Let's look at negative 2 here. At negative 2, this is the y value. At positive 2, this is the y value. What do you notice? They're the same. That's what it means when it says an even function. F of negative x is equals to f of x. Doesn't matter if you're negative on the x-axis, the y values will be the same. Whereas for an odd function, the y values, they flip. If you have a negative on the inside, it comes outside. If there's no negative on the inside, then there's only going to be a negative on the outside. Next, we're going to look into how to construct these plots. To do that, let's think about the unit circle. So there is a circle at the origin. I'll make a big one. Maybe we can even make it symmetrical, maybe. Something like that. Can I write on this? Okay, I can't. So this unit circle, there's an origin point. That's the x-axis. What we're gonna do is we're gonna find the x and y values for the circle at various angles. There's gonna be 4 values of interest. There's gonna be one here. I'll use a different color. There's gonna be one here at 0 degrees. There's gonna be one here at 90 degrees. There's gonna be one here at 180 degrees. There's gonna be one here at 270 degrees. Let's make a table. 0, 90, 180, 270. At 0 degrees, what's the x value? What's the y value? So we're looking at this point. This is a unit circle, so the radius is 1. What are the coordinates of this point right here? The radius of
0.
the coordinates. So it'll be x comma y. So it'll be something comma something. It's 1 comma 0, right? You agree or no? 1 on the
Yes.
x, 0 on the y. It's easier than you think. Okay, what about 90? It's just flipped. What about
0,
180?
1.
It'll be -1, 0. What about 270?
0,
0.
-1.
Yeah. And then it loops, right? It loops. So 360 is going to be the same thing here. 450 will be the same thing here. So you can use the unit circle to plot the curves of sine and cosine. Here's what you need to know. That x represents the cosine values and y represents the sine values. So let's start with sine. I'll do that in red. So sine is the y values. So on the x-axis, you have angles, okay? So 30, whatever, 60, let's go by 90. 90, 180, 270, 360. Same thing on the other side, 360. I'm looking at the table. We're plotting sine. At 0 degrees, the y value is 0. So we start at the origin. On the x-axis, remember these are your angles. At 90 degrees, the y value is 1. So let's say this is 1. Let's say this is -1. So at 90 degrees, the y value is 1. At 180, it's 0. At 270, it's -1. And then at 360, it's back to 0. And then let's connect it. And there you go. And because it's symmetrical, you can kind of like see the pattern here. See that?
Mm-hmm.
So that's how you draw the parent sine curve. Let's do the same thing for cosine. So the green is for sine. Now let's do cosine. At 0, it's 1. At 90, it's 0. At 180, it's -1. At 270, it's 0. At 360, it's 1. What do you notice about the blue curve and the green curve? How are they related? You see that they're almost the same, right?
Mm-hmm.
How much are they off by? How much would you have to move one by to overlap the other?
2.
2, 90 degrees on the x. Okay? 90 degrees on the x. So here's how I can phrase this. Sine, which is the blue, sorry, sine, which is the green. Let me just write it in the green. Sine, which is the green. If you take that sine function in the green, you move it left 90 units, you get cosine. Do you agree?
Mhm.
X minus 90, or it should be x plus 90, my bad. It's opposite. It should be x plus 90, then it would go to the left, right?
Mhm.
What about the cosine formula? Cosine of what gives me sine? So I'm on the blue, cosine. How do I modify this to get the sine? How many units to the right do we have to move it by? 90. X minus 90. Move the cosine graph 90 degrees to the right, and you get the sine graph. You get it? You have this blue curve, right?
Mhm.
You take this entire curve and you horizontally shift it 90 degrees to the right, and you will get the green curve. Do you see it or no? I can
I
do this
do.
on Desmos. Maybe it'll be better. So sine x, cosine x. Um, the issue with this right now is that it does radians, right? There we go. Degrees. We want degrees. That's fine. This is just to see the pattern. So now the blue one is the cosine, the red one is the sine. So now what do we do to the blue one to get the red one? So I told you that you need to move this by 90 degrees to the right, okay? Because we're in radians, 90 is degrees. Desmos uses radians. It also uses degrees, but it's not very user friendly. 90 degrees in radians is pi over 2. So what I'm going to do is I'm going to shift this blue curve to the right by 90 degrees, or pi over 2 radians. And what do I get? I get the red curve. You see, they're the same curve. They're overlapping on one another. Yeah? And then the same thing for the sine curve. If you have the sine curve, you want the cosine, what you need to do is then you need to move 90 degrees to the left. So you need to plus it. Plus makes it go left. 90 degrees is pi over 2 radians. And there you go. That's what I was trying to show. Okay? So what does it actually mean then? For us, it means that cosine of, let's say, 90 degrees is the same thing as sine of 0 degrees. They're complement events. You can look at it that way. Because the only difference between those two is a horizontal shift. Here's how they're related. Cosine of 1 is sine of 90 minus 1, 89. Cosine of 10 is sine of 80. Those two angles, they need to add up to 90. Same thing from the other side. Sine of 10 is cosine of 80. They're like the yin and the yang, okay? Not the best drawer.
Mhm.
You can say this is sine, the shaded part, and the non-shaded part is cosine. They add up to 90-degree right angle. Let's look at this plot. What kind of function do you think this is? What kind of function do we have? Is it a parabola? Is it x squared or x4 or is it something else? So it's probably a trig function. Notice how it's periodic. Periodic means it loops. Um, so it's a trig function. So we can denote this using a sine or a cosine, not a tan. Tan functions have asymptotes, okay? Tan is sine divided by cosine. Wherever cosine is 0, you'll be dividing by 0 for tan. So tan is not continuous. Sine and cosine are continuous. Yeah? So for this one, what's the maximum value approximately? What's the maximum y value?
-1.
What's the minimum y value?
-5.
-5. Uh, how long does it take to loop? So pick a constant. Pick one constant point. Like for example, if I pick -3 as my constant, it's not super obvious. Looks like it's like 6.5-ish. Let me pick a better point. If I pick this point, it loops over here. That's 6? No, it's a little bit more than 6, yeah? Let's say it's 6.5. You see what I did there? I was trying to see how long does it take for this function to loop. That one loop is called a period. To find the period, find a y value and stay with it. So if you're stuck with a y value of -3 here, you'll get this. So this is going to be your period. Cool?
Mm-hmm.
So it's here at 6.5. What's the midpoint? You can use your maximum and your minimum to see the midpoint as well. It's -3. Midpoint is simply you add two numbers up and you divide by 2. So the midpoint is -3. Cool? So the
Mm-hmm.
midpoint is right here. Now, what we're going to do is we're going to come up with an equation for this plot. And it's not as bad as you think. So it depends whether or not something is going through the midpoint. If something is going, or if something is starting, let me just say starting point. If something is starting at a midpoint, then you need to use a sine function. If something is starting at a maximum or a minimum, you need to use a cosine function. Actually, you can use either, but it's much, much easier if you use a cosine function for max min and if you use a sine function for midpoint. Otherwise, you're just making life more difficult for yourself artificially. So here, is this a sine question or a cosine question?
Sine.
Sine question. So here is the general form of the equation. Y is equals to A sine K x minus D plus C. So the four letters are transformations, A, K, D, C, they're back. So you just have to decipher those. And it's easier than you think. C is the midpoint. See this -3 here? That is going to be our C value. A is the distance from your midpoint to either the maximum or the minimum. What's the distance from the midpoint to the maximum or the minimum? 2
It's
units.
2.
Yeah, 2 units. So your A value is 2, right?
Mm-hmm.
We just have 2 more letters. D. If it starts at a midpoint, you're using a sine function, the D value is 0. That's why we use this. It's to make the D value 0. So if you're using a midpoint and a sine, the D value would be a 0. If you're using a max min and a cos, the D value will be 0. So in this case, because our function is starting off at origin, at the midpoint, sorry, at the midpoint, that's the starting point, our D value is going to be 0. Now lastly, you have the K value. K is 180 degrees divided by the period. So in this case, it's going to be 180 degrees divided by 6.5. That's in degrees. If you want radians, it's going to be 180 is pi. So it'll be pi over 6.5. That'll be your K value if you're using the radian system. So now let's put it all together. So y is equals to your A value, which is 2, times sine function because we're starting at the midpoint. K value is 180 divided by 6.5 times x minus 0. You don't have to write that if you don't want to. Plus c, and the c value is minus 3. And there you go. That's the equation. It's not terribly difficult. Let's plot it in and see if it makes any sense. So again, I'm going to change that 180 over 6.5 into pi over 6.5 because Desmos is better visuals with pi. And here's what we get. So the only thing I changed was, let me just try and plug this out. So the only thing I changed was the pi into 180. Does that look like that? It does not. Does it? Actually, hold. 10, 8, 15. This part looks good. Um, the min and the max is good. Min and the max is good, which means like the midpoint should also be good. What's off? Something's off here. The period is off. Is a period not 6.5? Let me try something. I feel like I messed up the formula. It's not 180. I see what the formula is. It's 2 pi over period. It's not 180. It's 360. So let me just change that pi into 2 pi and we should get the exact same thing. Just gonna change that pi into 2 pi because the formula uses 360, not 180. And now let's look at the plot. Does that look identical? Yes. And now we're good. You see that?
Mm-hmm.
So that's how you can come up with an equation for a sinusoidal function. It is pretty powerful. Could we come up with an equation for B using that method? What do you think? Could we come up with an equation for this? Or does that method not work? Is this a sinusoidal function? Remember what sinusoidal is? It's a trig function. Is this a trig function? is not. What do you notice about the curves? It goes up and down, right?
Mm-hmm.
By that I mean just like not the general trend. This would have been fine. That's a sinusoidal function. This is a periodic function, but there's some mumbo jumbo happening here. So our approach is not going to work for this question. It only works for smooth curves. This one's a complicated curve. In fact, this one is a combination function, which means so where's it starting? It's starting at a minimum. So it's cosine, but it's not cosine of x. It's cosine of something else. So let's see if we can we don't need to decipher. This is just for fun. So it went up and down. So there was a periodic function within a periodic function. So let me try this. Nope. Let me try this. Nope. That didn't work either. X to the EX. Whatever. You play around with it, you'll eventually get it. But that's how you can make complicated functions. You see, this is a periodic function. It loops, but it does more than just loop, right? It's having trouble even like zooming into it. So I don't know the exact equation for this function, but we know that it's a periodic function and it's a combination. Now let's go the other way around. Let's see if we can graph this function. And again, it's easier than you think. So this is a general form. A sine kx minus d plus c. C is the midpoint. A is the distance from the midpoint to the maximum and the minimum. K comes from the period. K is 2 pi divided by period, or 360 divided by period. So if you want the period, here the K value is 3. If you want the period, you can just do 360 divided by the K value. And here your D value is 0. Do you see that? The D value is 0 for this sine function. So where does it start? At the midpoint or at max or min?
The midpoint.
Exactly. So this sine function starts at a midpoint. I didn't tell you this before, but your A value, positive, it'll go up from the midpoint. If your A value is negative, so A is 4, doesn't apply to this question, but if your A value is negative, instead of going up from the origin, it'll go down. That's for sine functions. For cosine function, if your A value is positive, it's going to start at the maximum. That's for cosine. If your A value is negative, it's going to start at the minimum. Okay?
Mm-hmm.
So here it's going to start at the midpoint and then it's going to go up. What's the midpoint?
2.
And draw better curves. The midpoint is 2. So when you're sketching a question like this, always start at the midpoint because it makes your life super easy. So at 2, we have our midpoint. What's my maximum value? What's my minimum value? Remember, A is 4. A is the distance from the midpoint to max or the min. So your max is going to be 6. Do you see it? 2 plus 4. 4 units up from here. 2, 3, 4, 5, 6. That's going to be your maximum. What about your minimum? Where's your minimum?
-2.
-2. Okay? Are we starting at the midpoint? Look at the d value. The d value is 0, right?
Mm-hmm.
Which means yes, we're starting at the midpoint. And we're going to be going up because the a value is positive. Then we need the period. Period is 360 divided by k. So in this case, it'll be 360 divided by 3. The period is 120. So every 120 degrees, it's going to loop. So let's say that's 120, 30, 60, 90, 120. We can go in the negative axis as well. I'm out of space, whatever. So your period is 120, which means we're starting at the origin. We know 120 degrees later, we're going to be right where we started. Yeah?
Mm-hmm.
What you need to then do is understand the idea of quarter periods. Sinusoidal functions, they go up or down in 4 stages. Here, let's look at this. Goes up, goes down again, and then goes up. And that's one full loop. Doesn't matter where you start, as long as you end there. Uh, like that. Okay? Important part here is that it happens in stages of 4. So when you get your period, divide that by 4. And that's going to be your x-axis units, the scale. Why are we doing it this way? You'll see it's easy. So our a value is positive. We're starting at the middle because our d is 0. Every quarter period, you either go up or down. Look at this. So at our next quarter period, 30, because our a value is positive, we have to go up. Now the next quarter period, you can't go up from here. The only way to go is down. The next quarter period, you have to go down before you get to go up. Last quarter period, you finally go up. Same thing on this side. Idea of quarter periods. Is that making sense? I think you do this forever, right? Once
Mm-hmm.
you have a few, you can do it forever. And that's how you graph a cosine or sine function, a sinusoidal function. It's easier than you think. Start at the midpoint. You know, your a value gives you your max and your min, and then you just pretty much decipher your period. How can I make this question more difficult? Notice so far the d was what? 0, right? So I could make this question more difficult by giving you a curve or something that does not start at the midpoint. So it just starts at some random point. You see that? The midpoint is here.
Mm-hmm.
So that's how I can make this question more difficult. How would that change the answer? What that changes then is your d value is no longer going to be 0. Your d value is going to be the distance from where the y-axis to where the point should have been. It's not too big of a difference. That's going to be d. So in this case, it'll be sine x minus 20 or something to make up for that fact. You need to move it 20 degrees to the right. We'll see a question like this maybe soon. Let's first do this. Determine the coordinates of the point PXY resulting from a rotation of 70 degrees centered at the origin and starting at the point 3, 0. So all we care about is that point PXY. Let's look at this in more detail. Is this difficult? I don't think so. Let's draw a triangle, no? If I draw a line vertically down to the x-axis, I'm bringing it vertically down. That has to be 90 degrees. This is the x-axis here. And we're given that this angle here is 70. And what do we know? We know the radius of the circle is 3. So if the radius of the circle is 3, which side length of this triangle is 3?
BC.
BC is 3? No, that's not the radius of the circle. AB would be 3, right? See, this is the
Mhm.
radius, the radii, whatever, goes like this. It's like that. Yeah? See, it's AB, it's not BC. So that's gonna be AB. Okay, why is this question here? Even then, I don't think it's very difficult. So we're supposed to find the point B. All we have to do is find AC and find BC. Let's work on finding AC, the x value there. So AC is going to be the x value. Okay? This distance is AC, that's the x value. How do we find AC? Sine, cos, tan, or something else? Look at what you're given and what you need.
We use cosine.
You use cosine, yes. So cosine of 70 degrees is equals to the adjacent divided by the hypotenuse. So your AC is 3 times cosine of 70, which is 1.026. How do we find BC?
You can just use the Pythagoras theorem.
Yes, 2.82. And you're done. Easy peasy. Cool?
Mm-hmm.
So again, remember what the angle gives you. We did this earlier for unit circle. I use these points. X is the cosine value. Y is the sine value. So what is cosine of 70 degrees? Cosine of 70 degrees is the x value, which is AC. Okay, let's do another question. I'm not gonna do the weird ones. Okay, let's do this one. Something you'll see later is that you have to be careful of the, what should I call it, the coordinate system. Is this in radians or is this in degrees, and how can you tell? The answer is in the K. The answer is here. You see that symbol? That's
Mm-hmm.
degrees. Usually, not always, usually if a question is in radians, the angles are going to be in terms of pi. So you'll see pi. If you see pi, it's automatically radians. But pi is 3.14159. So sometimes they will like divide it. So like instead of saying pi over 3, they would divide 3.14 by 3 and they would get like 1.06 or something. That is still radians. So you just have to be careful. Radian values are usually low. Degree values are usually high. If the units is not given, it's not going to be, there's no gray area usually. So here we know the degrees given, we're in the degree system. So here your y-axis is the job applications per week, and your x-axis is the weeks. Using graphing technology, graph the function. Okay, whatever. Let's just pretend we put this on Desmos. Part B, how long is the employment cycle? In other words, find the period. How do you find the period? You can do it from the plot, or you can do it from the equation. Let me show you how to do it from the plot. Pick one nice point, if you can. There's no nice point here. So what I'm going to do is I'm going to pick this point of 6, and I'm going to see after 4 quarter periods, when does it reach the y value of 6 again? Remember, it's not this 6. That's only the second quarter period. 1 up, 1 down. That's not good. It has to be 4. So if you start here, 4 quarter periods would be 1 up, down, down, up right here. And then you see, well, what's that distance? I'm going to say it's 5.5-ish. Okay?
Mm-hmm.
So the period is, what's the x-axis unit? Where t is the time in years. Sorry, it's not weeks, it's years. So that's the period. That's when you wing it using the graph. The other way of finding period, or one cycle, right? Cycle just means period, is you do 360 or 2 pi over the k value. What's the k value here? Is there a k value? Is it given in the question?
It's 6.
K value is 6? No. Where'd you get 6 from? This is your A, 4.1. This is your K, 64.7. Your D here is 0. That's T minus 0, so there's no horizontal shift. We could have also seen that because it's a sine function that starts in the middle. This is your C value. That's not your K value. This is your K value. So you do 360 divided by 64.7. And that will be the exact period. Graphically, there's a little bit of leeway. Let's see what the exact one is. So it's 5.564. Cool?
Mm-hmm.
So know how to do using both. It says explain how you know. I feel like if you did this, you'll get full points. If you did that, you'll get full points. What is the minimum number of applications per week in the city? It's asking us for the minimum value. How can we find the minimum? Let's try and be precise. You're going to use the definition of the C and the A value. Again, it's easier than you think. The minimum looks like it's 1.9 or 2-ish, right? But we can be more precise. Remember, A is the distance from the midpoint to the maximum, yeah?
Mm-hmm.
This distance is A, this distance is A. So, well, what's the minimum value? Well, it's gonna be your C value, midpoint, minus 4.1. Your minimum value is 1.7. What's your maximum value? Same idea.
9.9.
Yeah, 9.9. Easy. What is the minimum number? 1.7. How do we know? Well, here. Graphically, you can get away with 1.9 or even approximately 2. Part D. Calculate J10 and explain what it means. So you can either plug that T as 10 on a calculator, or you can graphically, you can try and see what the approximate Y value is. So graphically, I'm feeling lazy, so I'm going to say J of 10 graphically is approximately 2. It's probably 1.99 or whatever. But because it's talking about job applications, it's perfectly fine if you round it up because it's a discrete variable. You can't really have negative or like decimal number of job interviews. So you can be like, hey, on average, there were 2. And that's the answer to part D. Um, After 10 years, so let me just kind of phrase this. This is the time in years, so 10 years. So after 10 years, there was 200 job applications per week. That'd be the conclusion. And you're done.
Mm-hmm.
So again, not that difficult, but do you see how useful it is? Like sine function, periodic functions in general. Can you think of something in nature that follows a cycle, that follows a trend? Weather, temperatures, right?
Mm-hmm.
What happens to temperatures? If you look at Jan to December, Jan is probably like the coldest, and then July is probably the hottest. Look at this. Goes like this, comes back down. You see that? So how do you think we model weather? What function? Sinusoidal. It doesn't matter, sine cos. These patterns, eventually we use technology, so we're not concerned with the d values. It'll spit it out for us. But we use sine cosine to model weather. What else is periodic in nature? Waves. How do you think we model waves? Shipping, like at 8 a.m., how high is the tide? At 10 a.m., how high is the tide? It's periodic, right? What do we use? Sine function. Um, pop pop quiz. Are the tides on Earth affected by the moon? Yeah,
Yes.
yes. So this is where that comes in handy, right? You can model
Mm-hmm.
the tides using a sine function. Many other functions. Basically, anything that loops, you can think of car engines. You can think of like a cell phone application. You can think of a marathon runner doing like sprints over and over. Anything that loops, use a sinusoidal function. Very, very useful. All these questions are the same. If you can do one of them, you can do all of them. Let's come up with the equation for some of these graphs for the last few minutes. So let's try and come up with an equation for the height of an individual on a Ferris wheel. So y, it'll be in this form. Y will be my height, and x or t will be my time. Y equals, okay. So let's look at the first one. Let's sketch it out. So there's a Ferris wheel. the axle, so this bit I think is the axle, is 8 meters above the ground. So this distance here is 8 meters. And the radius of this Ferris wheel is 7 meters, which means that this distance here is 3.5. Yeah?
Mm-hmm.
What will be this distance here? That is going to be 8 minus 3.5. Do you agree that that's the minimum point of the Ferris wheel?
Mm-hmm.
So that's at 4.5 meters. So that's at 4.5. This is at 8. What's the maximum height of the Ferris wheel? And it's again, it's easier than you think. If this distance is 3.5, the radius, this distance is also 3.5. So what's the maximum height?
11.5.
Yes. So it doesn't say where the Ferris wheel starts. Where does it start? It starts at the bottom, no? You get in here. Ferris wheel starts at the bottom. So is this a sine function or a cos function? It's going to be a cos.
Sine.
Anything that starts at min max is going to be a cos. So let's start filling things in. Y equals a cosine k x minus d plus 0. If something starts at the minimum maximum, you're using cosine, your d value is 0, so you can ignore that.
I have a question.
Yes,
How do you have 3.5? Like, where did you get that from?
right. So it said the axle, which I'm assuming is the center of the Ferris wheel, is 8 meters. Yeah.
Mm-hmm.
So what I did, and then what else does it say? It says that the radius of the Ferris wheel is what? 3.5, right? So it makes sense intuitively. Look at this. This height is 8, right? And the height, the radius of this wheel, this distance is 3.5. So what is this distance? 8 minus
But
3.5.
doesn't it say the radius is 7?
Yes, you're right. That's my bad. I thought that was the diameter. So that means our numbers are off then. Not by a whole lot. So that means that's 8 meters. If this is 7 meters, then the minimum would be 1, right?
Mm-hmm.
So the maximum would be what then? 15. Yeah?
Uh-huh.
Yeah, there we go. So sorry, I thought that was the diameter. My bad. Max, min. Now let's plug it in. It's very simple from here. Your d value is 0 because it's a cosine. A is the distance from your midpoint, which is what? 8 meters, right? Your midpoint is
Mm-hmm.
8 meters. So your C is 8. What's your A value? 7. Okay? A is the distance from your midpoint to the maximum or the minimum. The midpoint right now is at 8. So it's going to be 7 cosine. K is going to be 360 divided by the period. So 360 divided by 40, which is 9x. And because I'm assuming we're starting at the bottom, right? Intuitively, it doesn't make sense to me that you start at the top. Maybe some fancy Ferris wheels that you take an escalator, waste of time. We're going to assume this is a baseline normal Ferris wheel. We're getting at the bottom. Because you're starting at the bottom, your A value must be negative. And that's the final answer for this question, for A. So again, it's not terribly difficult, right?
Mm-hmm.
So if you're negative, if you're starting at the bottom, it's going to be negative. If you're starting at the midpoint and going down for sine, you're going to be negative. All right, cool. Let's call it there for today.
Okay. Thank you.
See ya.